In this tutorial we look at some of the highlights in OpenDetect release 4.0. As of 4.0, OpenDetect is a completely free seismic interpretation system. Complete because we have filled the last remaining gaps in a seismic interpretation workflow, and free because all of this functionality is open source and available at no cost due to a change in licensing policy. Here are some key features that are supported in OpenDetect 4.0. Well tie and depth conversion are new items in this list. 4.0 is released under a triple licensing strategy. The open source GNU GPL license covers OpenDetect. Under this license you can use all of the open source functionality for free, also if you want to use it commercially. The commercial license is for users who wish to access the closed source commercial plugins, either through lease or purchase. This agreement also gives you priority support. The academic license agreement is for universities only. It covers free licenses for the commercial plugins. The well tie module is new. You can now kick off an interpretation by matching your seismic to well log synthetics and in the process extract the seismic wavelet, either stochastically or deterministically. Well log displays have improved. Logs can be displayed as single lines or filled with single colors or color bars. 4.0 supports surveys in both time and depth. Elements can be converted on the fly from one domain to another, and volumes can be converted in batch mode. The conversion is either done via an existing velocity model, or you can use a model that was created with the new volume builder. More and improved gridding algorithms are supported to fill holes and to create 3D horizons from 2D horizons. For example, triangulation is now supported. It is also possible to create 2D horizons from 3D horizons. Color blending is also supported. It enables you to simultaneously display multiple attributes. The horizon tracker has been overhauled completely. The new tracker is more user-friendly and has much improved editing capabilities. Moreover, we introduce a new stepwise tracking option that makes tracking more robust. Hence you need less editing afterwards. The SegWi wizard is new. It facilitates data loading and features pre-scanning and previewing of SegWi files. If you have the memory, use it. You can now preload 2D, 3D and pre-stack data for quicker access. AVO attributes such as gradient, intercept and derivatives could already be calculated in the previous version. We now have added the possibility to pre-process the data. You can apply a mute, an HEC, vertical stack or velocity correction before the AVO attributes are computed. The generic remove tool makes it much easier to delete parts of a pick set or a horizon. Thanks to BG, who sponsored this and many other improvements, cross-plotting is now state of the art. You can select points in the crossplot and display these in the 3D scene. It is now possible to measure distances in a 3D scene. And you can quickly calculate volumes from a polygon to a horizon. We introduced default settings for colors and scaling. Each stored volume can have its own settings and you can select one volume to be your default dataset. Setting of defaults will save you hundreds of mouse clicks in each OpenDetect session. For every display element you can now display a histogram and an amplitude spectrum. Histograms can be used to adjust clipping ranges. The active color bar and the north arrow can be displayed in the 3D scene before you take a snapshot. What was presented up till now is all released in the open source domain as OpenDetect. In the next few slides we look at some of the highlights in the commercial plugins. SIS stands for Sequence Stratigraphic Interpretation System. This commercial plugin is the flagship product of DGB. In version 4 we introduce a new workflow called Multi-2D. This workflow can be applied to 2D and to 3D data. In the case of 3D, you start by creating a 2D grid in the preferred orientation from your 3D data. Next, you convert your 3D horizons to 2D horizons. And then you pick faults on the 2D lines. Now you compute a steering cube for all the lines in the grid. The steering cube is used to auto-track hundreds of horizons between the bounding 2D horizons. This is the so-called chronostratigraphy. The chronostratigraphy will not match at the intersections. We use it to make a systems tract interpretation, which we make consistent over the entire grid. Next, we derive system tracts boundary horizons. And finally, we can use the gridding algorithms in OpenDetect to convert these 2D horizons to 2 to 3D system tracts horizons. PDF 3D is a new plugin in OpenDetect by ArcGLS and Partner Visual Technology Services. It allows you to grab a 3D scene in OpenDetect and to save this in a PDF format. The file can then be opened in the standard and free Acrobat Reader software that nowadays supports 3D visualization capabilities like rotating, zooming, panning, removing and changing transparencies. Also new by ArcGLS in collaboration with Earthworks is a connection module. This module grows bodies from one or more seed points. It can be used, for example, to analyze the results of MPSI, the stochastic impedance inversion module. This concludes this tutorial on highlights in version 4.0.